Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop, and welcome to all the new subscribers as well. It seems that I have quite some traction here, and I do appreciate that very much. I want to give a quick little shout out to Shark River Machine. I got a boring bar from these guys when I was at the bash this year out at Stan Zinkowski's place. Used it the other day, really beat on it. It performed very well. It was real rigid, and I was quite happy with it, so thank you guys for the handout. Got it on an airplane too, by the way. I was quite surprised they let me take that on the airplane with the carbide tip in it. Once I told the guy what it was, right in, no problem. Anyway, today's video is about collets. Now, I've had quite a few comments online and offline about guys that have lathes that bought them with chucks, face plates, whatever, that don't have collets, and gee, I want to convert over to collets. It's going to be an expensive thing to do, and what collet do I select? Well, it doesn't really have to be expensive. It can be expensive if you buy top quality, and when it comes to collets, you're probably looking for concentricity and quality, so it may sting a little bit when you buy. Now, if I had to pick any collet for an engine lathe that I prefer over any other brand, it would have to be Hardinge brand. These collets are a little bit more expensive. I think you're going to find when you go looking in the catalog that that's a fact, but you get what you pay for, and buy nice or buy twice. And ultimately, if you have to buy another one because the first one you got was garbage, then you probably spent more than a quality collet in the first place. I'm going to walk out to the shop. I'm going to show you half a dozen different collet styles that I have, pros and cons of each one, what you could probably do to set your machine up with collets, and what to expect performance-wise if you go outside the design intent of each one. So let's take a walk out, show you the ones on the bench, show you a couple of different kinds. One that I've made and designed and works quite well. And I hope you get something from it. Let's take a walk. Okay guys, as most of you probably know by now, lathes have a variety of different types of chuck attachment nose cones. And my particular machine is set up for cams, 3 cams. I've seen them with 4, I've seen them with 6. I've seen them threaded, I've seen them keyed and threaded. There's a bunch of different kinds. But the one thing they're all going to have in common is some type of internal taper right here, usually for driving a live center. If you do not have collets in your machine, well, the first thing you're going to need is a nose piece, and you're going to need a drawbar and an indexer that goes all the way through. Now on the back side of your spindle, this is a 1340 Clausing Colchester. Great machine, I love it. This particular unit here goes through the back housing and is secured with set screws on the back side of the spindle. Now some spindles extend this far and they're threaded on the inside, and this whole piece here screws on. These little screws right here are to establish concentricity of this particular wheel, because if this thing is running out as the machine runs, the shake that you're going to get in your handle out here is absolutely annoying and unnecessary. So if your handle's shaking and you do have a collet set up, true this up. You can true it up with the ID indicator on the ID, or just go across the outside but move slowly, because the indicator is going to bounce quite a bit. This is the nose piece for the collet setup for a 5C collet setup, and on the inside of this one there is a key so that the collet doesn't spin when it comes time to tighten it down. The assembly is rather easy. Taper lock, and if you know the inside taper of your spindle and the outside taper of your collet that you select, making one of these should not be a problem. I don't see any reason why you'd have to buy one of those if you're on a budget. This is the closer setup, and most of these closers consist of the closer mechanism itself and the draw tube. Somewhere in the body of your draw tube you're going to find a Nikon camera strap. You're going to find a parting line right there. So it is a universal closer. The diameter will match the ID here, and then the length of the tube will be determined by the length of your spindle. So if you're ordering one of these out of a catalog, that's what they're going to be looking for. They may give you a standard to work from, which would be this, and then you develop the size of the bar that you need based on the dimensions that you get. And it's hard to do this with one hand. There you go. we are ready to rock. Once you thread the collet in there, the indexing wheel in the back has a lock on it so that you can maintain the exact same pressure each time. Pressure is dialed in by making it tighter or loosening the wheel in the rear. Let's take a look at a couple of different kinds of collets. Give me a second to put this on a tripod so we can stop the movement, and we'll get back to you. Let's start with one that you've probably never seen. This is one that was designed by me a couple of years ago. This is what I call a crown collet, and you'll see why I call it a crown collet. Because it looks like a little crown. One of the benefits to a style like this, and this was used in a milling machine, fixed to a fixture plate. Very tight tolerance because this was holding a poly part. And we could not have the part migrate down into the collet, so the recess that you see in the center here, the aluminum, is the actual stop. The OD of that particular stop that this spins on is the minimum diameter that this could close to. We did not want to distort the part. The cap itself has the closure feature on the inside, so it's tapered. And the stroke of the close was regulated by the cap itself. Has an internal stop, so it would only go down so far. And once you torqued it, that's it. It squeezes down, brass comes in contact with the aluminum, the crown closes into the minor diameter. The part registers on the back side like the stop here, so there is no migration of the part into the fixture, and all the work was done on the top. I can't be very specific because it's probably proprietary information and I'd rather not violate that. But that's what I call a crown collet. And I've used this several times, this particular concept, and it works quite well. Now, if you have a delicate part or a part that really needs to be controlled feature-wise, this is the way to go. Okay, let's look at some of the others. Let's take a look at some of the most common collets you're going to find in a machine shop, at least in my machine shop. If you're running a lathe, you've got to be very familiar with this guy right here. This is a 5C collet. It is only split from one side, normally split three ways, and that means that it acts like a hinge back here. And in a little while I'm going to post an animation and show you why this may not be ideal for heavy load applications. It has an internal thread on one end. You can set a stop, and as the stock size varies, this will go further into the receiving taper adapter that will be on your machine. So if you haven't watched the video that I posted called Great Setups, Crappy Results, and the Reasons Why, take a look at that video. It's going to open your eyes to a couple of problems you may have with collets like this. These are available incrementally in 1/64th increments, starting I believe at 1/64th, going all the way to about 1 1/8 inches. But as you get into the larger sizes, the amount of penetration you get on the collet gets smaller because you are restricted with the inner diameter of the rear. So comfortably you can pass 1-inch material through this and through your drawbar if your spindle is large enough. Okay, 5C collet, nothing special. You're going to find these on most mills. This is an R8 style collet, and if you were to adapt something like this to a lathe with a block or a piece of stock or whatever you want to make, please realize that these are pulled with a solid drawbar, whereby the 5C collet is a hollow tube which allows for much longer stock to go through it. I mean, up to 12, 14 feet, whatever you want to put through it, you can put through a 5C. An R8 style collet like this has a solid drawbar and would restrict you to the depth of penetration for whatever material you put into it. These are available in 1/8 increments and also split only from one side. These are ER series collets, most commonly found on milling machines, and I have to say that these collets probably have a greater grip range than a 5C collet or an R8 collet because they're split from both sides. As you can see, the The splits in the face of the collet are also present on the rear of the collet. So when this collet closes, the entire body of this collet shrinks down uniformly, retaining the cylindrical footprint of the through bore. So you're not going to have tangential contact with something like this if you use it on a bigger than intended part or a smaller than intended part. This is an ER32 size, and these are good, I believe, up to 3/4 or 7/8 of an inch you can put into an ER32. If I'm wrong on that, somebody please correct me. And this is an ER16. Now, the body size or the number, the ER32 whatever, the bigger the number gets, the larger the through hole capacity gets. It has no bearing whatsoever on how small you can get, because these collets hold exactly the same size diameter, but you can see this one is considerably larger. If you're going to make a collet chuck, if I was going to make a collet chuck for my machine, something quick and dirty, I would probably use an ER series collet because it's a lot stronger. And all I would have to buy, and there's a reason for this, would be the collet nut itself. An ER series collet nut has a feature on the inside that grabs the ER series collet. And that's because the ER series collet is not pulled from behind down into the holder like an R8 or a 5C collet. It's pushed into the taper by the cap. So when you unloosen the cap, I don't know, when you loosen up the cap with the spanner wrench or pins or however you're going to drive it, the collet itself would have a tendency to want to stay jammed down in the taper. So these collets incorporate a draw feature that will pull the collet out of the taper and relax the grip on whatever you've put in there. In the same way, it works the exact same way for the small ones. This is a collet nut for the 16, and they snap in, which makes these a little bit harder to expand beyond the size range that they've called out. But as far as squishing these things down and grabbing the part, you can collapse these things all the way till there's no slots whatsoever, and they'll still stay round. These are fantastic little collets. So as far as buying something to set up a collet system in your machine, if you're not going to buy a taper adapter for your spindle and a quick change or a drawbar tube, just buy one of these, get the thread specs, and make yourself a block that this fits right down into. Screw it on, boom, you're golden. Buy these as you need them, and you get more size range out of these too. You get about I would say you could probably squeeze 30 thou worth of diameter differences on a 5 or on an ER series collet. 32, 16, they work very well. I've never seen one of these in a tool holder, and this is the tool holder for the CNC. Going to get a little off track here, but there's a reason for it. You could, if you made something like this for your lathe, it wouldn't have to have all this fancy stuff on it. It could be completely cylindrical. You could have an internal thread where you thread something down, lock it in from the side, and when you put your collet in, your material would bump against that solid stop, and regardless of what happens to your collet, the collet will migrate as the collet tries to tighten up on your material, but the part itself is not going to migrate into the block because the stop is on the collet block and not the collet. That would be one of the drawbacks to the 5C style collet. As the collet grips down and slides in, the stop goes with it. So if the stop goes with it, and this is your zero plane, as the collet moves, the part was going to change in its length, sometimes longer, sometimes shorter, depends on the OD. Okay, ER series, super strong, much greater grip range between them. If you're going to make any investment at all, I would say buy the cap, make everything else. That would be dirt cheap. Buy these as you need them. Do not buy these size specific. If you can, buy the ones that come in a range. It'll tell you, 140 to 115 or 780 to 680. See if you can find the ones that come in a range. You'll probably spend a whole lot less money and be able to squeeze a lot more stock. Watch out for the through hole size. Know your application on the jobs that you're going to do. Know how long the parts are that you're going to work with. Know your budget. This will help. Okay, let's look at the animation. I'll show you why these are so much stronger than the 5C and the R8s. What we have here is a wooden cross section of how any collet system is going to work. This would be the nose cone taper, whether it's a collet chuck, whether it's the nose cone, spindle nose cone for your machine. This is the cross section of the collet. This is the material. With a collet like this, which is pivoting about the back, solid in the back, solid in the back. It's only split part of the way down. Like a 5C or an R8 collet, you can see that the performance of that particular collet under nominal ideal conditions will be congruent on the taper and along the material OD, completely along the material OD. This assures that the material doesn't flop around. Now these types of collets are designed specifically for nominal size material and cutter shanks. So let's put something in there that's not, well, it's not a 1/2 inch, but let's call this a 1/2 inch blank. Let's knock this out and put in something a little bit smaller. And I'm going to show you that it's a little bit smaller. Okay? Let's call this 492. Just because that's halfway between the 1/64th incremental collet size you would get. Put it in there, you're putting your material up in your stock rack and say, hey, this material fits in this collet. Okay, let's stick it in there and close it. As you close it, you can see all kinds of interesting things happen here. The geometry intended to be congruent on the outside of both sides is out the window. You have gaps up in the nose, you have gaps in the rear, and you have wiggle in your material because it's only held at the tip. This is if you put a smaller material in a nominal size collet. Okay, one more time. Squeeze it down. Let's take it out and squeeze it down and see how it really reacts. You can see what's happening there. You can see the taper, and it's just nothing good is going to come from this. Let's put bigger material in. I'll put the 1/2 inch back in there, bring it down to congruent, show you that it's congruent. Let's take a bigger piece. Not much bigger, nonetheless. You're looking for material, you say, let's just stuff it down inside this collet right here. So as you stick it down in there, now you have completely opposite what you just had. The collet hits on the outside and the material hits on the inside. Also not good. This is going to cause a taper in your part. It's going to cause chatter. It's going to cause all kinds of problems, and you're not going to know why. If I had to say, okay, we don't have a collet for that particular size, like this right here, wrap your part with paper, wrap it with stainless steel foil, wrap it with aluminum foil, anything that you can measure, and make sure that it gets close. And then when it comes together, it's going to come together and perform like you want it to. One benefit, only one benefit to using a collet that is too big. Let's use smaller material. Using a collet that is too big for a piece that's bent. Let's say you have a 6-inch long rod that you've already choked up on it in the machine, pop the center drill in it, then you extend it all the way out, close it again, and it's wiggling. It's not going to go straight because the collet, if you're using a nominal size collet, it's going to hold it straight, and the end of your material is just going to whip. By using the next size up, when you close that collet on that material, it's going to hold at the very front and allow the back to move a little bit. So you can bump it until your center is running true, take a very light cut until the next nominal size collet, then reverse your material in the next nominal size collet and squeeze it like you should. So there's a time and a place to cheat with collets of different sizes, but the 5C series Style Collet and the R8 size collets are designed specifically for ideal nominal conditions of stock size and cutter diameters. There you go. Okay, let's put the ER series collet style in here, which closes front and rear, and look at the difference. With the collet being split in the rear and the front, very much like these guys here, like I showed you before, these are split 8 ways from the front and 8 ways from the back. There is a much greater grip range on a collet like this than the standard 5C or the R8. And this is why, because when they move parallel. The front and back close at the same time. So it doesn't matter if it's the 1/2 inch nominal size that it's intended for, or a bigger size, or the smaller size. There you go. It's always going to be congruent because it's moving along a wedge configuration. You're not getting any of this because there's a hinge thing going on. It's hinging, but it's hinging in the front and back at the same time, therefore it closes parallel. Alright guys, well, for what you've seen, I guess you could probably decide on what type of collet would best suit your application, and no reason that you can't make an adapter if you're within the ER family. If you have an ER collet series or an ER collet size, collet chuck, that's a larger size, no reason you can't make an adapter for the smaller sizes as well. But know exactly what's going to happen when they start to move and migrate based on the diameter that you're holding. Anyway, I hope you got something out of that. There's a lot of different kinds and different sizes. Some are stronger than others. Fact. That's why milling machines use ER series and not a 5C or that type of style. Anyway, hope you liked it. Hope you got something out of it. Leave me a question, comment, thumbs up if you liked what you saw. Joe Pye, Advanced Innovations, Austin, Texas. I'm out.